Alright, so today we're going to be talking about spheres. We're going to be talking specifically about the volume. Surface area, we're going to hold off on that because we're going to discuss the surface area of many different things all in one video. So today we're just talking about spheres and their volumes. Now, the key phrase here is in space. What that means is that this is actually a three-dimensional object. That's what makes it different from a circle, is that a circle is on a flat surface. A sphere is in space. So if you take a look at this picture right here, it's a really good example of what a sphere looks like and being put on a two-dimensional plane, i.e. your screen. So in order to create the perception of a sphere, you kind of have to give it that depth, okay? Alright, so the formula for the volume of a sphere is 4/3 pi r cubed. This formula will be given to you on your test, so there is no need to memorize it. So, given the sphere with a radius of 7, find the volume. Well, we know volume is 4/3 pi r cubed. So for r, we're going to put in the radius of 7. Okay, so type it into my calculator. I get 1,372 pi over 3. Now change this to a decimal because the directions don't say pi or decimal, so I want to give you both. And it's approximately 1,436.8 inches cubed. Now here we've been asked to find the volume as well, but notice that I've been given the diameter instead of the radius. To find the radius, I cut the diameter in half, so 24 divided by 2 is 12. So volume equals 4/3 pi r cubed. Now the radius is 12, so that's what I'll plug in here. And I get 2,304 pi inches cubed, and it did say leave in terms of pi, so this is my answer. Alright, a sporting goods store sells exercise balls in two sizes, a standard and a jumbo. How many times greater is the volume of the jumbo ball as compared to the volume of the standard ball? So what we need to do here is first off find the volume of the standard ball, 4/3 pi r cubed. Now the diameter is given, so I would divide by 2 to get the radius. And then when I type in my calculator, oops, that's a 5. Alright, so that's the volume of the standard size. And then the volume of the jumbo, so I'll put a little J here for jumbo. 4/3 pi r cubed. Now the problem is it was 34, so 34 divided by 2 gives me 17 for my radius. And type in my calculator, that's what I get. So what I need to do is I actually need to take the jumbo ball and divide it by the standard ball, and it will tell me that the jumbo ball is approximately 3.7 times larger. Okay? Alright, what I'd like for you to do is pause the video and try number 1 on your own, and then unpause when you're ready to check your answer. Hopefully you already have the problem worked and you are now ready to watch. What you have here is I put in 50 for the radius because we've been given a diameter of 100 centimeters. So you had to do 100 divided by 2 to get the radius. Alright, so when I plug this in my calculator, I get 523,598.8 centimeters cubed. Now for this second problem, it says we want a sphere that has a great circle circumference of 83.92. Now before we get too far, I'd like to discuss what a great circle is. Basically, a great circle is any time I take a sphere and I slice it directly through the center. So if you were to think of the Earth, okay, if I were to slice the Earth right at the equator, that would be a great circle. Okay? Or if you were to take, let's say, an orange and cut it right down the middle. You know how when you were kids you used to take like potatoes and stuff, and you could paint them and make little stencils out of them. That's basically what we're doing. It's a really tiny slice of the circle of the sphere. Now, every great circle splits a sphere into two hemispheres. Oh, there's a lot of S's in this, isn't there? So let's look at this in a picture format. Okay, so here's the Earth, and I have sliced the Earth directly in half, going through its center, through its core. Okay, notice it does not necessarily have to be the equator. It can be the equator, or it can be at an angle, as long as it passes through the center of the circle. Now, that great circle that we have created creates two equal parts of a sphere called hemispheres. Alright, so what we need to do here is we need to find let's see, it says find the volume at the top in directions in red for each sphere, given that the circumference is 83.92. So this is our circumference, 2 pi r. I'm going to replace C with 83.92 because that's the circumference. Now it's my job to solve for r. Divide both sides by 2 pi. Alright, I'm left with r on this side, so 83.92 over 2 pi in my calculator is 13.4 meters. Now I can take that information and plug it in the formula for volume. And there we have it. There's the volume of a circle that has a circumference of its great circle of 83.92 meters. Alright, what I'd like for you to do is pause the video and give number 3 a shot. Now that you know what the great circle is, given that the great circle has an area of 70.58 square feet, find the volume of the sphere. So pause and give it a shot. Alright, recall that the formula for a circle is pi r squared. If I know that my area is 70.58, I plug it in for A. Divide both sides by pi. I get 22.47 equals r squared. To get the square off of r, use square root both sides. So r equals 4.7. Now that I have my radius, I can plug it into the formula for volume. Alright, and there we have it, 434.9 feet cubed. So hopefully you have checked your answer. Alright, so I want to throw in one extra problem. It's probably not on your note sheet, but I would like to discuss this in order to help you with the assignment that we're going to complete in class. Okay, given that I have a sphere of a volume 40,000 pi centimeters cubed, find the radius. So remember that volume equals 4/3 pi r cubed. So, in order to plug in, I would plug in 40,000 pi, it's a lot of pi, in for V. And now I need to solve for R. 4/3 and pi are being multiplied to R, so I would divide both sides by 4/3 pi. Now you can actually do a fraction inside of a fraction on your calculator, and I would do that to not make it quite as complicated. So what you get when you type this in your calculator should be 30,000. Now the problem is that whenever I had a square root, r squared, I would square. Okay, I got cut off there. Sorry. So when I had r squared, I would square root both sides because square rooting and square are the opposite of each other. So if you go back and take a look. Right here, r squared, we square rooted both sides to get the square off the r. However, this is being cubed. So what we're actually going to do here is something called the cubed root. Okay, inside the square root is a 3. To find it on your calculator, you're first going to type 3. And then if you look above the symbol, there's a symbol like this, a little arrow, it's called the caret symbol. You'll see a button that looks like x square root. That's what we want. Notice that it's in green. That means that I'm going to have to hit the second button and then the caret button in order to get x square root. And what you'll notice is that when you type this in your calculator, you're going to get this, the little cubed root of, and then you are allowed to type in our case, 30,000. So when I find the cube root of 30,000, I get 31.1 is the radius of this sphere. Okay? So if you're having trouble with that, just let me know. This works the same for anything, so if I had x to the fourth equals 16, if I did the fourth root of both sides, I would get that x equals 2 because the fourth root of 16 is 2. Okay? So if you have any questions on that, just let me know. If you have a different calculator and want me to see where your buttons are, just show me and I will talk to you later.